Hi everyone, I wanted to take a few minutes to go through the assignment on inverse trig functions. I know that it's a little bit of a harder topic. It's a little bit confusing at first. I think if I go through some of the problems that were on the assignment, that might help to kind of iron it out in your mind and show you how you can approach each of the problems. So if you remember from the lesson, the first thing we said that is when you're dealing with the inverse sign. So if I have y equals inverse sine of x, remember that that only exists from negative pi over 2 to pi over 2, which is the same as negative 90 degrees to positive 90 degrees. So your answer must be between those two values. For cosine, it only exists from 0 to pi or from 0 to 180 degrees. Again, your answer must fall between those two values. Okay. For tangent, notice the difference. Here I have parentheses, and the reason that I use parentheses is because it can't actually equal that value. So over here, you can have an answer that equals negative pi over 2 or pi over 2. Here you can have an answer that equals 0 or pi. But here, you can't actually ever equal negative pi over 2 or positive pi over 2 because the inverse tangent doesn't exist there. So that's why this one has parentheses when this one has square brackets. So let me show you how we're going to approach some of these problems. Problem number 1 on the assignment. This is exercise set 4.7. And the problem was sine of negative 1 of 1/2. Okay, so I can actually rewrite this as theta, or the sine of theta rather, is equal to 1/2. So I'm trying to find the angle whose sine is 1/2, right? I'm basically doing this. Theta is equal to inverse sine of 1/2. That you can actually do right in your calculator. Okay, so you can go to your calculator and you can, clear that out, and you can say just second sine of 1 divided by 2, and it's going to give you an answer of 30. So theta is 30 degrees, but we should always put our answers in radians. So 30 degrees in radians would be pi over 6 radians. Okay. Problem number 3 says sine inverse of radical 2 over 2. Okay, so basically I'm saying the sine of some angle is square root 2 over 2. Now the first one and this one you should recognize. This comes out of your special right triangles. But you can do that in your calculator, and you could say second sine, and you can say root 2 divided by 2. And it'll tell you that that answer is 45 degrees. So we get theta is 45 degrees, which in radians is pi over 4 radians. Now, if you go to the next one, problem number 5, it says sine of negative 1/2. And so here's where, if you do it in the calculator, sine to the negative 1 of negative 1/2. You can certainly do this in the calculator. It's going to give you the correct answer. But what I want you to understand is what's actually happening. So let me show you what happens when you put it in the calculator. Negative 1/2 or negative 0.5. And it gives you an answer of negative 30 degrees. So your answer here is negative 30 degrees, which in radians would be negative pi over 6. The reason that it's negative is because it has to fall between negative 90 degrees and positive 90 degrees. Okay, so your calculator is programmed to give you an answer in this correct domain, or in this between these two values. It gives you an answer of negative 30 degrees. The reason for that is this. If you think back to this ASTC, right, that tells you what's positive in which quadrant. Because the inverse sine function only exists from negative pi over 2 to pi over 2. It only exists from here to here, right? From here, from the first quadrant to the fourth quadrant. So it only exists in 1 and 4. That is from negative pi over 2 to positive pi over 2, right? This is negative pi over 2. This is positive pi over 2. So it only exists between those two values in quadrants 1 and quadrant 4. Because it's negative, I know it can't be the first quadrant because everything's positive in the first quadrant. So it would have to be down here in the fourth quadrant. But again, I have to write it as an angle between negative pi over 2 and positive pi over 2. So I can't say, oh, well, it's let me change color. I can't say that it's this angle here, because that measure would be more than 270 degrees, right? This would be 90, this would be 180, this would be 270. That would be greater than 270. That's not between negative 90 and positive 90. So I have to go this way and count the negative angle. And that's why your answer is negative 30 degrees instead of positive 330 degrees, because it has to be in this range. And that's why your calculator gives you an answer of negative 30 degrees, which when you change it into radians, it's negative pi over 6 radians. So let's look at problem number 7. Problem number 7 says inverse cosine of root 3 over 2. Okay, you could easily do that in your calculator. If you did that in your calculator, you would get second cosine of root 3 divided by 2. Whoops, hold on. I think I entered it in wrong. Oh, I entered it in wrong. Okay, let me redo that. So inverse cosine of root 3, have to close the parentheses before I hit the division symbol, divided by 2. And that gives me an angle of 30 degrees. So in this case, theta is 30 degrees. In radians, that would be pi over 6. Problem number 9 is then in, it's a negative. So it's inverse cosine of negative root 2 over 2. So inverse cosine only exists from 0 to pi. So if you're looking at your graph, that would be from here to here. Remember, in the first quadrant, everything is positive. In the second quadrant, cosine is negative. So I know this is going to be a second quadrant angle. I know that the angle whose cosine is root 2 over 2 is 45 degrees. So if I'm in the second quadrant, I would do 180 minus 45 degrees, which would give me 135 degrees, which in radians would be 3 pi over 4. Let's check it in the calculator. Second cosine of negative root 2, close my parentheses, divided by 2. And you'll see that gives me 135 degrees, which in radians is 3 pi over 4. All of these problems you can do in your calculator. Okay, if I did number 11, cosine of 0, inverse cosine of 0. The angle that has a cosine of 0 is pi over 2. If you think of your cosine graph, right here is where it hits 0. That's pi over 2. And pi over 2 is between 0 and pi. So theta here is going to be pi over 2. That you can check in your calculator. Okay, so you can do all of the problems in your calculator, but I just want to show you what it is you're actually finding there. So hopefully that helps, and that'll help you finish the rest of that assignment out. All right, everybody, thanks.